Okay, so welcome everyone live or watching the recording. This is a US-RSE funders talk. We have today two folks from Schmidt Futures that I'm looking forward to hearing from. So just looking at the bio and just picking out a couple of things. Stu Feldman is the chief scientist of Schmidt Futures, and I think the most interesting thing to me is that he wrote Make, which kind of is hard to believe that a single person did that, but great. And James Ricci is also here, who is a director at Schmidt Futures with some history at some other organizations. It's kind of interesting as well. But I'm going to try to let them talk rather than me talk. And so I would say, take it away, and we'll go ahead and give you time to talk, and then ask some questions. And then if you have questions for us where you're interested in point of view of RSEs, we will try to answer them as well, and we'll see if there's any discussion. So go ahead, Stu and James.
Hello, can you hear us?
Yes, sounds good.
One of the first questions of did mute come off? Thank you. I'll just say a few words and hand off to James, but basically we support a lot of work in scientific fields, both talent programs and projects in a variety of the sciences. Many of them involve heavy computing of one form or another. My own background as both a personal software engineer, yes, I did write Make among other things, and my miss or well-spent youth, we can go over that some other time, and running large software projects at places like IBM and Google and Belcor, given me great respect for what a full-time serious software engineer can do, and how that is very different from the likely output of a faculty member or a graduate student. They may be really smart and insightful, but they're extremely part-time and focused on getting something to work once. My usual comment is a PhD student has only one job, and that's to get out of here. And anything else is in the way. Excuse me one moment, a emergency cord is showing up.
You can just click there, sure. Thank you.
Sorry, electricity is a necessity. So therefore, we have been very supportive of using real software engineers, not just part-time students on our projects. We're willing to pay the market surcharge. I have had the pleasure of telling a number of college presidents and provosts that if they want to be serious here, yes, they will be paying programmers, software engineers, coders, choose your local phrase, more than perhaps your basic professor. And that's life. And that I'm sure that the football coach is not paid more than a professor either, so there shouldn't be a problem. But that usually ends that part of the conversation, of course. However, very seriously, we at Schmidt Futures have been very supportive. James will tell you how we have been doing it, but we have supported over 100 RSEs on our various programs and projects, and expect to do more. Thank you, James.
Great, thanks, Stu. Yes, it's very exciting to be speaking with you all today. And as Stu kind of laid out some of our motivation and approach in general as we have gone through this. We'll give a brief overview of some of the different programs that we have and some specific examples of different projects that include RSEs as we go through, and then hone in on a specific, very relevant program and example to dig in deeper. But as Stu had mentioned, in general, we have a variety of programs that go across from our talent programs that focus on individual science researchers at a variety of different career paths or career points or aspects in their that can really help them as researchers themselves be doing more, to some institutional transformation programs and projects that focus specifically at universities or institutions to help build infrastructure or transform them in some way, and I'll dig in a little bit more. And then our virtual institutes of science that work across a variety of different disciplines, from climate modeling with our Virtual Earth Systems Research Institute to astrophysics or ocean biogeochemistry and artificial intelligence. And a lot of these have advanced computing at its core throughout this, but also the programs in yellow have projects and even across the program some core RSE teams and support through there. So we have been supporting a variety of different RSEs and projects in a few different models that we have gone through and done this. First, I'll just talk about what I think is more the typical model of we choose research projects that we think are particularly relevant and want to support, and that have a good software need in it, and then have them embed RSEs within that. So a few examples of us doing this with larger collections of RSEs is having these projects that are supporting for a longer period of time, and having them choose RSEs that are being directly recruited by these projects' PIs through their institutions, and that get fully integrated within their research teams. So in the upper left, CLIMA, which is our Climate Modeling Alliance, is a coalition of scientists, engineers, and applied mathematicians from Caltech, MIT, and NASA's JPL. It created a new open source Earth system modeling toolkit through an open development process comprising of 30 plus active developed repositories with about 150,000 lines of code, has received many recognitions and awards. Then our cell annotation platform includes researchers and engineers from the Broad Institute, Harvard, the Technical Institute of Munich, and Wellcome Sanger Institute in the UK, and have RSEs working on developing this platform to help provide annotations for cells within the Human Cell Atlas and beyond, and really focused on a user-friendly platform for researchers with having RSEs that also have particular UI, UX expertise in there. The Radio Camera Initiative is an end-to-end pipeline it's based out of Caltech, and it's built in collaboration between professional software engineers and astronomers to prototype hardware and software technology within our Virtual Institute of Astrophysics. Another example from Astrophysics 2 is our LINK, which is an initiative of the LSST Corporation and its member institutions. And it consists of research and engineering teams that span two primary locations in Seattle at the University of Washington, and then in Pittsburgh at Carnegie Mellon and University of Pittsburgh, with roughly half the team in each location. And each of these locations hosts 2 or more research scientists and about 4 to 5 research software engineers with local tech leads and a centralized engineering director. So we have several other projects too that do this, but key thing here is that these are more the traditional method of having RSEs embedded in these specialized domain-specific projects, as I think we typically see. Another method that I had mentioned earlier is through our institutional transformation programs, which focus on individual universities or institutions. In this program, we aim to increase the use of advanced computing technologies and encouraging the creation of interdisciplinary research teams. So 2 examples are the Accelerate program at the University of Cambridge, which aims to accelerate science pursues research at the interface of AI and the sciences, generating new scientific insights and developing AI methods that can be deployed to advance scientific knowledge, and consists of a couple senior RSEs and several early career scholars, and focused within Cambridge itself, or Princeton DataX, which is focused on developing a more robust data science infrastructure at Princeton to accelerate scientific discovery. And here they have hired several RSEs as a part of this initiative, and we are already seeing a shift in culture through Princeton's, through a commitment to hiring a number of RSEs across campus and outside of this program. But here in general, I want to also highlight one of these institutional transformation projects at Caltech called the Schmidt Academy for Software Engineering, which takes a different tact and is really focused on training and recruiting new, here it's recent Caltech and Harvey Med computer science graduates, and then it will embed them in Caltech research projects that need quality software development. So this is a project and program here that's been running about 5 years, and it's a method and ways that we can try to attract really promising recent CS graduates away from industry and to learn some more quality skills in research software engineering, and seeing if we can teach them these skills as they want to consider a path in academia instead. It's led by 2 software engineering instructors who help teach these core software engineering skills. We've already seen 33 early career RSEs in the program, 19 of which have graduated, and many of which we have seen pursue either PhDs or academic career paths, and 14 current ones. And so this is a model that we have used for early on training of this that we think is promising, and also leads into one of the programs that I want to hone in on more here, which is the Virtual Institute for Scientific Software. So we have seen, as noted earlier, many different RSEs that we're supporting across a variety of different projects and programs. And instead of just more doing it in these kind of more common and traditional means of supporting them in these different isolated pockets, if we could have a more conscious effort into how we can create critical mass of scientific software engineering expertise in several locations, and establish access to different talent pools and multiple experienced leaders. That is a way that we can kind of shift this model to attract more individuals into the research software engineering world. So the model here is to accelerate the pace of scientific discovery through developing robust, well-engineered software and supporting longer-term platforms and systems, encouraging best practices in open science and providing access to techniques such as high-end computing, massive databases, and machine learning. This is a model that was launched in early 2022 and consists of 4 centers that are hosted within specific departments and institutes at each of these 4 universities you see listed here. So Georgia Tech sits within the Georgia Tech College of Computing. Johns Hopkins, the center there, is hosted by the Institute of Data Intensive Engineering and Science, IDEAS, within their AIX, which is a new pan-institutional initiative at Johns Hopkins. University of Washington, the center is embedded within the eScience Institute. And then at University of Cambridge, we have our Institute of Computing for Climate Science, ICCS, which is hosted by the Departments of Applied Mathematics and Theoretical Physics, and comprises of a collaboration between Cambridge Zero, these departments, and the University Information Services. This Cambridge ICCS also supports research projects primarily within our Virtual Earth Systems Research Institute. And how we created this program, one aspect that's unique is that about 80% of the software engineering efforts and projects are dedicated to coming from people within, researchers within our network, and about the other 20% are then sourced internally by the centers. So instead of having this be really internally focused within the infrastructure of the university, supporting a much wider net of research projects and tools that are spanning a wide variety of locations. We purposely have created each of these models in a different way. So I would say in one sense there isn't a typical structure across them. That each of these we wanted the flexibility to be able to build a center that fit within their university structure. But there are some commonalities between them. Each of these has a director and 2 to 3 faculty leads that served as that kind of primary initiative building aspect of the university. And then they would hire a engineering lead, so which would be a seasoned software engineer, generally with over 20 plus years of experience, really will sit as that nucleus for the entire center. And which is, we found, is difficult to find and recruit from industry to bring into academia. But once you do so, serves as that impetus for kind of really forming a team that will consist of maybe 2 to 3 senior RSEs or several also associate RSEs or more junior software engineers as they're being developed there. We have been very successful. Each of our 4 centers do have center engineering leads now that come from a variety of expertise from Microsoft and Amazon to several startups experience, or people who came from the academic system too, a professor of research software engineering and ex-president of the UK's Society of Research Software Engineering, and really have come together to form an interesting team. And these models also incorporate different components too of ICCS, for example, has postdocs and early career fellows that are looking at a longer term horizon embedded into the program. Or one of the centers also includes a technical project manager and a human-centered design engineer who can look at this, the more of the social science between involved in scientific software. So we hope to learn from these different aspects of being flexible both for what the university needs, but also seeing what components are really helpful and necessary in these types of centers and models. So where are we in this model and in this phase? We are currently finishing year 2 of an initial 5-year program. And each of the 4 centers are almost fully staffed. There are still the plug of some open roles at these. If anyone is interested, I encourage you to look at these different centers on their web presence. Please feel free to connect with me, and I can pass you along to those open roles as well. We have been completing the first round of projects and have initiated a second round of projects already. And we are starting to see some early wins and or progress from these centers, including RSEs and researchers that are expressing some excitement and satisfaction and learn lessons from these collaborations. One thing I'll put out front of some basic policies that we have here is we make it very clear up front that we expect any code from projects to be released as open source as much to the extent as possible, and encourage the inclusion of RSEs as co-authors on any research publications when they have made a significant intellectual contribution. And we're starting to see them now coming through as co-authors. And we use letters of collaboration between the centers and PIs before that work begins to outline these clear expectations, timelines, and deliverables as they work through. So to that point, some of this process as we go through, as I said, about 80% of these projects are sourced from outside of the university. So this is the first time that they are engaging with these researchers that vary in their academic careers from postdocs through very seasoned PIs. They work across domains. And the way that we go about selecting this is we have a call for expressions of interest. from members of our network to provide about 3 to 5 page proposals. We have scientific and technical reviews to look at the feasibility and potential impact of each project. We pair them with centers we give them to the centers for review for further evaluation and rankings. Then we have a process of potential revisions for the submissions where we go back to the PIs to help answer any questions, revise any particular aspects of them, and then begin a pairing process with the centers with the ones that we are deciding to move forward with. And that's when, from our end, we hand over and pair them with the centers and allow them to take it from there and begin that initial engagement for further scoping and that creation of that letter of collaboration. We see projects that are around 6 to 9 months, so medium-term projects, not multiple-year, long-term projects. That's more of when we think RSEs maybe should be embedded within the projects themselves. And making it very pointed that this is not a call center either for just these short-term, quick, can you review my code, or can you just add this little feature in here and do that. The way that RSEs are designated or paired with these varies depending on each center and their approaches in the project, and that is fully run by the engineering leads and the centers themselves. So we're excited at this in general to see how this continues to develop and across this as a model. We have gotten some early learned lessons in here. Particularly, it took longer to, we thought it was going to take a little while to hire the quality that we expected from industry, especially for that engineering lead. It did take longer than we had even expected, but that actually came out to, we are extremely encouraged and pleased by what the results are.
Of course, COVID intruded
on
our timeline.
Yep. And this also included some aspect with negotiations of not just recruitment, but from the university standpoint of making sure that they are internally moving those salary bands or approving of the proper titles and lines. And here is where we have seen some initial funding from us, in that case, gave that nice little kick and interest from them to actually start doing these and provided that impetus that has lifted up salary bands or created new lines across the university and helped make a more systemic improvement there. In speaking with some of the RSEs too that have been recruited, that first the engineering lead is often a catalyst for recruiting and can really serve as both from within their Rolodex and network of finding good people, but also as people who really want to work with someone like that. But then we've heard from the RSEs too that working in this team setting, working with other RSEs across a variety of different projects, and they're not the sole RSE who's working on soft money in this in a project and always trying to look at what's coming next. But being able to work with code reviews and bounce some ideas off of someone right next to you is extremely exciting, and especially as you think about career development and training into these new aspects. And so working across these different projects and types is extremely supportive and of interest as well. We are still early on in this model, and so are learning along the way as well, and have identified several ongoing areas of improvement, including now looking at once we have recruited and have these, how are we looking at effective ways to train our RSEs? How about the training and resources available for the PIs that are engaging with software engineering, maybe for the first time or with little experience for this? And so with this new type of model that is only for a limited engagement, how can we better prepare them coming into this with good expectations and ways to prepare so that when they do have that engagement, it's more effective. And also thinking about longer term after that engagement ends, supporting them for making sure that they have the understanding and knowledge and impetus to sustain this over time and engage with a broader community as well. We're looking at effective assessment strategies. I feel like that is common across the board, especially for funders, of how can we effectively assess and measure the impact of these different aspects in projects. Also with this model that we have here, looking at how do we have effective initial engagement and wrap-up strategies for these medium-term that new domains, and they're coming maybe into a project that has already been being worked on or is in that middle aspect of it, and how do we effectively have a clean and efficient engagement to begin with, and a clear wrap-up strategy to hand it over. And we've seen some interesting differences in perspectives from how industry approaches this and how people with more academic backgrounds approach some of these, and finding maybe a happy medium between these two different styles too of what is most effective for research software engineers. So I think with that, that kind of gives a broad overview, but want to really just say thank you for this opportunity. Look forward to hearing what questions we have and what we can dive in deeper to. I'll give the full program team and say too, if you have any questions or follow up on this at all, please feel free to contact me, or just there's the email there for the VIS team at Schmidt Futures, and the team that we have, program team that works across this VIS. So with that, I can open it up for questions. Or Dan.
Yeah, no, that's great. Sorry, I'm hopefully sounding okay. I turned off my video because I'm getting an internet unstable message. Assuming that this is okay, I guess I'll just ask potentially as a semi-critical question to start off, and then we'll see if we get friendlier questions after that. I'm curious, in some sense, when I look at the program and the opportunities, I see opportunities for RSEs to move to some of the universities that you're funding. I don't see the other kind of option about how people who are in a university could get involved in these programs without moving. And so I think my question is really a general one about how to get involved in some of these activities, how to find out about potential future funding calls, and to possibly expand some of these things if that's something that you would be interested in at some point.
Yeah. So I think one way that we are thinking about this is first engagement with the broader community, with the RSEs too, of doing aspects like this and engaging with that and looking at this. But for this, it is still just in this year 2 of this program as we are doing this. And the universities and the centers within those universities are finding ways that they are engaging more with that university infrastructure and the researchers that are there, in the hopes that over time that is going to build up and engage more. We'll get more university buy-in there, so that it isn't just a temporary center that is funded by us and then no more, but how do they actually engage more broadly? And each center is doing that in their own ways. And we are also, in general, looking at this and across the board of, as you can tell, we are very we think RSEs are critical to scientific research and progress in general across the board on a lot of different areas. And we are actively thinking about new ways in which we are doing that, and looking at these different models and how they do work and where we think there is additional leverage in there. Anything else that you want to add?
Also, we are intentionally being decentralized here. We at Schmidt Futures are not the hiring agents. We are enabling various centers, various PIs to do their own recruiting. These being explicit, the RSEs are not our staff; they are staffed of the universities. This is a university-based program so far.
Okay, yeah, thanks very much. I think I guess the slight issue kind of that I see is just the fact that it seems like a relatively small number of universities that are getting a number of awards, and just thinking about how that potentially could be expanded. So more of a university question than an RSE question specifically, but I understand where you are now. So Ian, you have a question.
Yeah, thanks. Thanks for joining us. My name is Ian Kazan. I am the director of the Central Research Software Engineering program at Princeton. So the one that you alluded to, the centralized group that we're growing.
Yes.
Um, and also I wear another hat where I'm the chair of the steering committee here at US-RSE. So I have about 8 questions. I'm only going to try to hit on one where I see that we have very similar goals here of trying to um, achieve some institutional change, support for RSEs at various institutions. And I'm curious how you're viewing the sustainable funding future for some of these. Is the expectation that these places where you're establishing the VISS, the schools, that over time they become self-sustaining with funding, and kind of how can we help make the case to other institutions to set this up on their own without your seed funding? Is this something you've thought about, and sort of what can we do to spread the word and make that case?
Well, let me be just direct that our funding is finite, both in duration and total magnitude. Yes, we are funding at any time over 50 RSEs, but that is quite a lot of money, since, as you can calculate. We have been eager to talk to a variety of universities about how they could actually do better themselves. Yes, I've spoken to the past and current provost, as well as the president, in your case, Ian, about this one, for example. We are not pretending that we are going to solve the problem en masse. I've spoken to a variety of universities since, given my regular job, as I do have no problem talking to VPRs and provosts regularly. And I've had some actually interesting responses, and then I point them to places like Princeton and Oxford, which are making real investments of their own money. But so far as I can see, there has been a salutary effect of our coming in and saying, let's actually do it somewhere, for other universities to start seeing that there is a model that they can operate. No, the RSE problem is at one level totally trivial. Just pour in money and the rest gets solved. Well, okay, having now reduced it to an insoluble problem, now how do you get this done smart? And we are happy to work with you as an organization with any ideas. I personally am very committed to making this finally making a change. I got tired after 25 years of talking to NSF and NIH about how this would be a good idea, and everybody saying, yeah, sometime. Well, now it's time.
Yeah, I think I would add there too about at these universities, really part of this was looking at this as a different type of model that is still experimental in terms of not just, we are seeing a sea change in different universities wanting to support more software engineers, but not having do so, looking at it more as from the viewpoint of how do we actually create a more sustainable model of that, and not just have this individual soft money of, yeah, we'll provide a line for the grants to do this, because as many people know here too, for RSEs looking for career paths, that is not very sustainable, and it's hard to recruit people over for that. So how do we actually provide and point to some examples and ways that this has been successful that could then hopefully serve when talking to other universities, or they can point to this as saying like, no, this is a better way, or not. We can go through, as we go through doing this, we're going to see some ways that it has been successful or not as we go through.
I will point out that one thing we attempt to do is collect data on it works. Having professionals actually make software that doesn't fall apart upon graduation day really changes the research profile and the research outputs. And those are data we think will be extremely useful in such conversations. Thank you.
Yeah. We totally agree.
It's interesting.
Good, Dan.
Sorry. Yeah, I was going to say it's interesting to look at this compared to the Moore Sloan Data Science Environment program, which has some similarities, and then which kind of led into the ADSA activity that now has, I don't know, 100 universities that are all kind of going forward with data science programs, and wondering then if there's some way that we can use the existing US-RSE and its strength to try to do something similar and try to make RSEs maybe more, I don't know, more well understood by more universities as well. Sandra is next.
Yeah, thank you. Yeah, I'm Sandra Gesing. I'm at the Discovery Partners Institute at the moment still. So I'm the executive director for US-RSE from November 1st. And I would be very much interested in yeah, collaborating, especially also with the outreach to the different, because one of the plans is to say, yes, we want to advertise that, you know, the successes of RSEs. I fully agree to all the points you are saying. So it would be great to collaborate on the outreach to the universities which don't have the groups yet, which to talk, and you started it already with talking with the provost, so maybe we can, you know, get some synergies there, and because that is one of the plans, reaching out to people who don't know about us yet and about RSEs. And if we can join forces there, that would be fantastic.
Well, very nice to hear from you, Sandra. I'm just writing down your name here. Thanks. Using old-fashioned technology, right?
Yeah.
Okay, Chase is next.
Hi, I'm Chase Millian. 15 years ago, I left Caltech and started a company that does research software engineering because there was nothing at Caltech that would allow me to do professional software engineering to make science better. I now have 5 full-time RSEs. We've done a lot to impact science, in my opinion. So, and my first question is, are you willing to talk to me? I don't work at a university, not going to work at a university, but I think I've learned a lot. And I'm very interested in software being improved so that science can be improved. And I've been thinking about it a long time, and I have a lot of on-the-ground experience. Question 1. Question 2, do you have any plans or screening criteria, or any ideas about the science engineer, the software engineering lead and the RSEs you're hiring also having some baseline level of scientific competence? So it's not just that they're excellent software engineers, but that they are actually able to quickly understand the needs, purpose, and interests of the scientists they're working with.
Yeah, so I mean, to that second question here, I think that is one thing that I'm particularly interested in, and I think the centers are approaching it from a variety of different ways and are getting teams that are pretty diverse in there, from several that actually have PhDs in the sciences and then went on to do some actual software engineering, not just as a component of their research, but learning those skills, versus ones that are maybe just have a previous degree, undergraduate degree in a science, but then went off to software engineering and industry for a long time, to ones that are really just focused on that industry and software engineering and seeing how do these teams come together and what are the pros and cons from both of those, and learning from these engineering leads who are doing those recruiting and doing this to see like what do they see as a good mix in those. And I think we have learned lessons across each of these different categories. And I mean, my perspective in general of like hiring too many of ones that have a particular background isn't maybe as good as finding ones that can bring in some of these different perspectives, and there might be a mix in there and do that. But yeah, to your point, what is some of that baseline of, if you're going to be working on some of these hard, serious science research, we're going to know what a PDE is, or going through and doing this so that there is some shared language and you're not completely talking past each other.
But we do seek in most of these programs, this program's a variety of backgrounds, and people who are really good at, for example, managing large data may not themselves be specialists in a real value simulation. The program at Caltech, I chose Caltech specifically because I figured no Caltech grad would be afraid of the letter D, and we wouldn't have to worry about that at least. However, others, considering that what's about to hit is the machine learning revolution, there's a whole new set of skills that are different than the classic applied math curriculum that are going to be needed. So I'm assuming that we will see a very different admixture of backgrounds looking 24 months from now. So one needs to be aware of, even of the shifts in the classics.
Okay, thank you. Gerard is next.
Yes, hi, my name is Gerard Lemson. I'm the Associate Director for the VIS Center at Johns Hopkins. Hi, Stu and James. Since you brought up that you had been trying to persuade the NSF to start focusing also on RSEs, 2 weeks ago I was in Houston and an NSF meeting for CSSI PIs, that's Cyber Infrastructure for Sustained Scientific Innovation. And there was quite some discussion about RSEs there as well and how they can be brought into these programs. I talked with one of them, Kenton McHenry, that some of you will know, I suppose. And we were talking about indeed the salaries of these RSEs, that they were supposed to be close to industry standards. He said, no, don't, because at some point when the funding falls away, then NSF would have to take over, and NSF may not want to take over higher salaries. And so I discussed it also with the program manager for our particular project, Varun Chandola, and he saw that, yes, if there is value to RSEs, then maybe the NSF should start taking that seriously, the salaries for those people. But maybe there should be particular ways in which to bring RSEs into the projects or whatever. So I'm curious for yours, but also other people from the RSE movement who are here, what your thoughts are on how to get NSF and other funding agencies be willing to start supporting this, and whether we can persuade PIs that one RSE might be worth 3 graduate students or 2, 3 postdocs.
Well, I'm glad that the conversation at least went in the positive direction, but it sounds like it hit the usual reef and how are we going to pay for it? And NSF reviewers looking at budgets and noting that grad students are so much cheaper than professional software engineers. And I dearly hope that NSF will finally have a phase change on this. And I'm glad that you and some others are actually working on them again. Sorry for my cynicism that I've given up after too many rounds. You're basically suggesting maybe it's time that I place a cheerful call to Panch and suggest this is something that he ought to think about.
I guess just to make one quick comment on this, Varun gave a talk in this series, I don't know, a few months ago, and that's recorded and available if you want to see his comments on software engineering and what NSF is thinking at this point. I think he's personally interested, but in some sense, an individual program officer at NSF has much less flexibility and power than, let's say, a chief scientist at Schmidt Futures. And so things move more slowly. I think discussions that you would have with him would be quite helpful, or with Panch. Chase.
Yeah, so I don't go through NSF, but I go through NASA, and there's been a change in the last 5 years, especially, but the last 10 years, where review panels rate very, very highly that you've brought on a professional to do certain parts of the task, and NASA does not balk at all at the price tag. Mm-hmm. So the culture change is possible. NASA made it. I know NSF is much bigger.
It's a big difference between a mission agency and one of the research agencies. The mission agencies, in my experience, actually understand that sometimes you have to pay to get the mission done. And it doesn't pay to use cut rate mechanical engineers on your spacecraft either.
This may be true, but I'm talking about the research and analysis
Yeah,
parts
but
of that
just
also.
it's just the agency culture.
I understand.
In my experience, the ones that are mission oriented actually are used to doing a trade-off based on you want mission, get it done right, and NASA even budgets for long-term data operations rather than throwing it over the wall. So it's a major culture difference in my personal experience, and a very good one.
That makes sense. Thank you.
So given that we've got about 10 minutes left, what kinds of questions would you be interested in hearing from us about?
I am curious how you picture, in my view of the RSE question is almost entirely a university issue, because at least as I've seen it, organizations like national labs and mission-oriented agencies seem to view hiring software people to do scientific and technical work to be just part of what you do. And yes, you pay some market-related amount for it. However, perhaps you are seeing something different, and I'd be very curious about the university, non-university divide or distinction, excuse me, as you're seeing it.
Yeah, Sandra, did you want to comment on this?
Yeah, I would like to comment on this. So what I've seen, I totally agree that the national labs are further along with RSEs, but there's still also the lack of that they're not all called RSEs. They're not all, brought together in a community. So I think there is definitely also the need for making it clear that it's a great career path for them. It's also national labs are still lacking a kind of great career path often. Not all, but quite a few. So I think, yes, academia is more behind, but national labs have definitely, we have a national lab Slack channel, for example, out a working group where they're discussing what are specific problems for national lab RSEs, and there are some similarities still with academia.
Interesting, thank you. James, have you?
I might take also one of Chase's questions and throw it back in terms of you. What do you think some of the good experience from RSEs in terms of level of scientific domain expertise, pairing with software engineering training from a variety of different fronts, and how those engagements with PIs and embeddings work in there? Is there any thoughts? I mean, first maybe for you, Chase, and then others open up of what do you think that good background is?
The approach I'm taking, which we've trial run over 4 onboardings now, so not a huge data set, but some, is that I take people with scientific training formally of some kind, at least an undergraduate degree, maybe a master's or PhD, with a little bit of programming. And then I teach them to be excellent software engineers, which I have luck doing over about a year if they have the aptitude and the interest and are willing to focus for that long. And then additionally, we teach people, we teach the people we onboard how to get up to speed very, very quickly in other domains in which they might not be experts. So the idea of like a specific domain of expertise doesn't exist here. Whatever our client, who is a PI at a university, whatever they're working on, we become absolute experts at it at the same level as they would expect a postdoc in their lab to be, as quickly as possible. So between those 3 things, in my experience over and over, it's allowed us to make really substantive contributions and even push the edge of the state of the art in whatever specific problem we've been hired to help address.
I'll just say really quickly that at NCSA at Illinois, we're kind of partly what Chase is doing, but we're kind of the opposite as well, that we really try to get people kind of on both sides and then have them learn from each other about the other side. So we definitely hire people that are just computer science bachelors who maybe know a little bit about a science area, and then try to get them working with an RSE who's kind of on the other side to form a team, and then they learn from each other. Ian.
Yeah, I think I want to kind of agree with both of these statements already. I've hired from both ends, hired from people who only have academic background in the science that have picked up the software engineering along the way and continue to grow, to the, kind of traditional software engineering industry experience, wanting to work on something, say, more socially interesting and wanting to transition over into, the research side of things. I find that kind of the attitude towards learning new things and capacity to learn those new things, it's very rare to hire someone with the exact right scientific background for that particular project all the time. They have to be able to come in and kind of understand it quickly and get up to speed, and then over time develop in these embedded groups. As Chase said, I see a lot of them become as domain experts as the postdocs in the lab, bringing with them with the software engineering. So I think it has more to do with kind of individual background and a foundation on one of them that they can then build on top of from there. So I've become, early on, someone said to me once that research software engineering is like underwater archaeology, and that it's easier to teach an archaeologist how to scuba dive than it is to teach a scuba diver archaeology. And I thought that was a really great analogy until I started to see literally us teaching scuba divers our archaeology, and they were picking it up, and it was possible, and it was able. So I sort of have backed off that analogy into saying that it really is there really are advantages to hiring from different places as long as you fit in the research culture, and there's lots of ways to make that work.
Thank you.
All right. Do we have any last question before we wrap up? I guess not seeing anything immediately. I'll just make one final comment regarding the university issue that I think Stu was asking about before. I think that's one thing that maybe US-RSE hasn't done as well as it could, is to work more collectively with universities. I think we've all worked kind of individually with our own universities, and there's been work done through things like the Ricci Funders Forum that's trying to work kind of collectively at a high level, but not really at a university level. And so maybe that's something that we should be thinking about, is how do we work together with all of our universities? The UK strength has been a couple of universities has moved forward, and others use them as examples to encourage their own university to catch up. I don't think we're quite doing that either. So this might be an interesting thing that we should be thinking about within US-RSE. Okay, so with that, I think we will end. Stu and James, thank you very much for your time.
Thank you.